Hey guys, hopefully this video should be mostly review of some stuff you've done in the past with right triangle trig. So anytime that you have a right triangle, which this one is, and it'll be indicated with the little square in the corner, that is the right angle, you can use SOHCAHTOA. So hopefully you've used SOHCAHTOA before to find like missing sides and angles in right triangles. So we're going to talk about that a little bit today. So we have this angle theta, and theta is just a Greek letter and it represents whatever angle you're talking about. So say that I want to be talking about this angle as we go through this video, then I'm going to call that angle theta. And theta is just written as like an O with a line through it. So if I was talking about this angle, then I can find the sine, cosine, and tangent of theta for each of them. So first of all, I'm just going to label like what each of the sides are. So for sine, if you remember, that would be like the opposite side over the hypotenuse. And that's why it's OH after the S. For cosine, it's adjacent side over hypotenuse. And then for tangent, it's opposite side over adjacent side. So if we're using this angle theta, then the opposite side is going to be the side that's physically across from it. It's going to be the one that it's not touching that side at all. So this is going to be the opposite side over here. The hypotenuse is the one that's always across from the right angle. So, and it's always going to be the longest side as well. So we have our hypotenuse over there, and then the adjacent side is the side of the triangle that the angle is touching that's not the hypotenuse. So this bottom side down here is going to be our adjacent side in this scenario. So then if I wanted to find sine, cosine, and tangent of this angle theta, then I would just go through and I would find the values for these. So sine is going to be opposite over hypotenuse. So that's going to be 4 over 5. Cosine is going to be adjacent over hypotenuse. So that's going to be 3 over 5. And then tangent is just going to be opposite over adjacent. So that's going to be 4 over 3. So it might help you if you go through and label the triangles like this before trying to find these trig functions for theta. Okay, so then today we're going to get into a few new trig functions as well. So we already have sine, cosine, and tangent. Those are the ones that you already know. Something that you don't know about tangent potentially is that tangent is opposite over adjacent, but you can also find the tangent just using sine and cosine, because tangent is going to be the sine of an angle divided by the cosine. So that's something you're going to want to make a note of. And then our three new trig functions, this CSC, that's called the cosecant. And then SEC is the secant. And COT is the cotangent. And so you're going to want to know like what those words are. So you might want to write that down. And then these are just the abbreviations, just like SIN is for sine, COS is for cosine, and stuff like that. We got really used to these. So just make sure that you write down like what the actual words are for cosecant, secant, and cotangent as well, so that you know what I'm talking about whenever I refer to them. So if you look at these, the cosecant is going to be 1 divided by the sine. Secant is 1 divided by cosine, and then cotangent is going to be 1 divided by the tangent, but it's also just going to be the cosine divided by the sine. So basically what's happening, like whenever we were talking about sine, that was opposite over hypotenuse. If you look at cosecant, it's hypotenuse over opposite. Cosine is adjacent over hypotenuse. If you look at secant, it's hypotenuse over adjacent. And the same thing happens with tangent. It's sine over cosine or cosine over sine for cotangent. And then for tangent is also opposite over adjacent. So if you're just looking at a triangle, cotangent is adjacent over opposite. So what happens is each of these with the corresponding one across from it the one that's across from it is going to be its reciprocal. So that's going to be something that is good to remember, because if you have the sign of something already, it's easy to find the cosecant by just either flipping the fraction or by putting 1 over the sign. And then the same goes for the other trig functions as well. So then we're going to go through for this triangle and we're going to look at all of the different trig values for theta. So on this one, theta is over here, it's this angle. So I'm going to go ahead and label what each of the sides are. We know that that's the right angle. So across from theta is going to be the opposite side. The longest side is the hypotenuse, and then the one that theta is touching, but it's not the hypotenuse, that's the adjacent side. So for sine, we need opposite over hypotenuse, so that's going to be 5 over 13. The cosecant is just going to be the reciprocal of that, so that's going to be 13 over 5. For cosine, it's adjacent over hypotenuse, so that's going to be 12 over 13. And the secant is going to be the reciprocal, so it's going to be 13 over 12. And for tangent, you can do opposite over adjacent, so that's going to be 5 over 12. And for cotan, it would be the reciprocal, so it would be 12 over 5. But I also want to do tangent the other way, where it's sine over cosine, just so you can see it done, so you know how to do it like this in the future. So if you have the sine is 5/13, and then you're dividing that by 12/13, then that looks weird because you have fractions in the numerator and denominator. But remember that this is just division, so you would have to multiply by the reciprocal. So basically 5/13 divided by 12/13 is going to equal 5/13 times 13 over 12. So then whenever you're multiplying that out, you can, I can't remember the word, it's like cross simplify or something like that, where if you have a number in the numerator and denominator, then those are going to simplify out to just be 1. And so then you would just in the numerator have 5 and in the denominator have 12. And then that is the same tangent that we got by doing opposite over adjacent. So just keep in mind that you can do the sine over cosine method if you're not necessarily given all of the sides or whatever. Also, keep in mind if you are not given one of the sides of a right triangle, that you are going to be able to use the Pythagorean theorem. So that's just the a squared plus b squared equals c squared. So say that you weren't given this 5, but you were given the 12 and the 13, then to solve for the side 5, you would just have to do 12 squared plus b squared equals 13 squared, and then you would solve it out from there. So you would end up like subtracting the 12 squared to the other side. You'll end up getting b squared equals 25. And then you would take the square roots. I'm not going to go through the whole Pythagorean theorem process unless you guys need me to later, but just keep in mind, like, if you are missing a side, it's not necessarily an accident. I think I put some on purpose like that on the homework because you do need to know how to do the Pythagorean theorem as well. Okay, so then here's a time where knowing the sine over cosine rule for tangent is going to come in handy, because you need to know the tangent on the unit circle as well. So remember, on the unit circle, we have cosine as our x values and sine as our y values. So if I wanted to find the tangent at 30 degrees, then I would have 1/2, which is the sine, divided by the cosine, which is the square root of 3 over 2. And so then I would, to divide the fractions, I would have to multiply by the reciprocal, so it would be 1 over 2 times 2 over the square root of 3. So then our 2's are going to cross out, and you would have 1 over the square root of 3. But then, I don't know if you guys remember, but you're not supposed to have any radicals or square roots in the denominator, so you have to rationalize this 1 over the square root of 3. So to be able to rationalize something, you're going to be just multiplying by the square root that is in the denominator, in the numerator and denominator. So you'd be multiplying by the square root of 3 divided by the square root of 3. And this isn't something that's going to be like super duper important for you guys to know, but just to be able to find the tangent, you will have to do this occasionally. So basically, the 1 times the square root of 3 is just going to give you the square root of 3, and then it's going to be divided by the square root of 3 times the square root of 3, and I'm just going to do that up here so you can see it. And whenever you multiply two square roots like this and it's the same number on the inside, you're going to end up just getting that number. But just so you see how it works out, it would be like the square root of 3 times the square root of 3. That's going to equal the square root of 9. And the square root of 9 just gets you back to 3. So the tangent there at 30 degrees is going to be the square root of 3 over 3. And then the next slide, I'm going to show you what all the rest of the tangents are as well. But that's how you would do it for all of these. Some of them work out a little more easily, like at 45, the square root of 2 over 2 divided by itself, it's just going to be 1 for the tangent, and so on. But I am going to show a slide right here that has all of the tangents for the entire unit circle, and these are already rationalized. Even if we were in class in person, this isn't something that you have to memorize. It's just something that's good to know. And then, like, yesterday we were solving for things like sine of x equals the square root of 3 over 2. So that could be a question that could be asked on a quiz or test, is like if the tan of x equals the square root of 3 over 3, then what would x be? And you would have to look at where the tangent is the square root of 3 over 3, which happens at 30 degrees and at 210 degrees. So just know that those types of questions are fair game at this point. And I'll also post this picture. I posted a link under this week's work that's just says unit circle. It's just a picture of the unit circle so that you guys can reference it. I'll post this picture there as well. So then for this table, I kind of just want to talk about how it works. You don't have to worry about filling it in on your own. But we have the cosine of theta, and then we have sine of 90 minus theta, and we have it for each of these degrees. So you're trying to find these two values for each of these degrees. So to do that, you would essentially just type in cosine of 0 or cosine of 20, and so on into your calculator. If you are doing that in your calculator, make sure your calculator is in degree mode, or you're going to get a different answer for these. And then for the bottom row, the sine 90 minus theta, so it would be, these are the theta values in this top row, so it would be like sine of 90 minus 0, which is just 90, or sine of 90 minus 20, which is 70, and so on. So that would be how you would type them in the calculator. I'm just going to pause here and go ahead and fill in the table so that you guys can see the relationship of what the values are. Okay, so now I've got the table filled in, and what you should notice is that for each of these values, the cosine of theta is going to be equal to the sine of 90 minus theta. So that's just one of those rules that you need to know. So we're going to write it out. The cosine of theta is equal to the sine of 90 minus theta. And then that's going to work in reverse as well. So you're going to want to write this down too. The sine of theta is going to be equal to the cosine of 90 minus theta. So then a time that you can use that is when you have something like number 11D on your homework, where we have the cosine of theta equals 1/4, and we're trying to find some of the other information about it. So for example, the secant would be 1 over the cosine, or it would be the reciprocal, and stuff like that. So I'm not going to give too much away about this. I will say on this homework assignment, for a lot of these, I would say probably 3 through 11, it definitely helps out if, well, maybe not 9, but on some of these, it helps out if you draw a right triangle and go through and label the sides. because on 3 through 8, you're going to have to find a missing side, and then you'll have to label that and use that whenever you're going through. And then on 10 and 11, I believe that it helps out a little bit with those two. But that's kind of it for right triangle trig. So this is going to be the homework assignment. I know it's copied twice on this page. Don't worry about that. But just look at one side of it, and these are the types of questions that you're going to be asked to find the answers to with right triangle trig.